Hello and welcome to the Daily Space for today, September 19th, 2019. This Thursday, we find ourselves continuing to be bombarded with planetary news coming to us from the European Planetary Sciences Congress that's currently taking place in Geneva, Switzerland. And our first story actually introduces us to a case of figuring out how to do something on Io that we haven't yet figured out how to do here on Earth. And that's predicting the eruption of volcanoes. The volcano that you see here is Loki Pantera, which is located on Saturn. No, I had it right initially. That is located on Jupiter's moon, Io. This particular volcano was, along with all the rest of the volcanism over on Io, identified initially in March 1979 by the Voyager 1 spacecraft. As the spacecraft flew past, it was able to see a eruption of, Loki bright along the terminator between the bright and shadowed part of Io, and a plume from a different volcano erupting up over the edge of this object. And Io is home to some of the most massive volcanoes in our solar system. And when I say massive, I'm not messing around. When New Horizons flew past Jupiter and its moons many years ago, it was actually able to observe an eruption of, and here I'm going to get the name correctly, an eruption of Tvashtar. And when that volcano went off, it erupted material 330 kilometers up above the surface of Io. If a volcano here on Earth was to have an eruption that large, the ash would get within 50 kilometers of the International Space Station, well into what we term outer space. Now, Io's largest volcano is Loki, which is the one we're talking about today. And Loki, when it decides to be big, doesn't mess around either. It is a full 202 or 126 miles across, and it contains a vast lava sea. Now, this particular volcano has been regularly erupting ever since it was first noticed more than 30 years ago. Now, when I say a volcano erupts regularly here on Earth, I'm referring to our ability to say that a volcano maybe erupts roughly every 10 years, or we think roughly every 200 years. But these estimates that I use for volcanoes here on Earth are kind of the more or less, but don't count on it and don't make any plans based on these predictions kinds of predictions. We can't accurately predict without the last minute earthquakes occurring when a volcano is necessarily going to erupt, at least not here on Earth. Loki, because it is different, because it is massive, because of the forces that drive its eruptions, it appears to be a little bit better behaved. This particular volcano was observed over and over during the 90s to erupt roughly every 540 days. And more recently, these volcanic eruptions have sped up to occur pretty much every 475 days, give or take a few days or weeks, not years. Now, guess what? It's time for one of these volcanic eruptions to start. According to Julie Rathbun, the Planetary Science Institute scientist who is responsible for determining these periodicities, we think that Loki could be predictable because it is so large. Because of its size, basic physics are likely to dominate when it erupts. So the small complications that affect smaller volcanoes are likely to not affect Loki as much. However, you have to be careful because Loki is named after a trickster god, and the volcano has not been known to behave itself. In the early 2000s, once the 540-day pattern was detected, Loki's behavior changed and did not exhibit periodic behavior again until 2013. Now, if Loki behaves, like I said, it's going to go off in the coming days or weeks. So this is one of those times when you should tune in and be ready to make your observations. This kind of work requires a lifetime of commitment. You don't notice these kinds of periodicities and changes and behaviors with just one or two observations. You really have to look at it over and over, dig through the archives, and keep looking if you want to study cosmic change of any kind. And it's Julie Rathbun who's been doing these observations since the beginning. Well, not the observations, but the analysis. It was her 2002 paper that noted the first periodicity, and it is her presentation that occurred this week at the European Planetary Sciences Congress, or EPSC, that, lets us know to go outside and look up. Now, if you want to see these eruptions, you're not going to see them with the backyard telescope. When I say go out and look up, I actually mean if you have access to something like the Large Binocular Telescope out in Arizona and you're working in the infrared, go out and look up. These observations are best done with a spacecraft, but we don't currently have one that's pointed directly at Io. What we do have is ground-based telescopes that are capable of seeing the dramatic brightening that occurs mostly in the colors that are indicative of something being warm and giving off infrared light. So look in the infrared light with massive telescopes or a spacecraft that I don't know about that maybe one of you has, but probably not. Anyways, continuing on to our next story, we have a tale of, ice. This is Enceladus, one of the moons of Saturn. And this particular moon, it was discovered in the 2000s, has geysers. Geysers that spew ice and water that becomes ice and snow vast distances through the Saturnian system. On Tuesday, planetary scientist Alice Legal presented new research that indicates these geysers act as snow cannons and may be partly responsible for the shiny, bright white surfaces we see throughout the rings and on the surfaces of Saturn's moons Mimas and Theus. Now, this also plays in with a story we ran a couple of days ago that looked at the fact that Saturn's moons, or rather Saturn's inner rings, are much brighter and whiter than we're otherwise thought about. Now, before you start saying the conveyor belt theory that we talked about a couple of days ago is not right, I want to point out the geometry of this system, where Enceladus is out in the outer areas of the rings and was not part of those pristine white surfaces that were looked at in order to try and get an age for the rings. So here we're talking about a different area, but the same problem of super shiny white surfaces. In work that was done by Legal and her collaborators, they were able to determine that it would take tens of centimeters or half a foot or more of fresh snow on each of these surfaces to get the kinds of highly reflective detections that they're able to make using radar. And that's a lot of snow. Consider this. A geyser on Enceladus is responsible for snowfall 50,000 kilometers away. While I'd love to send another probe out to make detailed observations, I am quite glad that Enceladus and its snow cannon is located a vast distance away from the planet Earth. Now, this is a cool new result, and it's more complicated than just there being tens of centimeters of snow on these surfaces. The radar detections that they're getting also indicate that beneath the snow, there must be some sort of geological feature, surface, that is allowing these radar echoes to come back so loud and clear. This could be cavities such as you get from sunlight melting into the snow or craters forming or other interesting features. Whatever's going on, we do actually need to send more probes out there to get a better understanding of what's going on. And I do want to say, yes, I understand. If you took Enceladus and you put it where our own Earth's moon is, it wouldn't be throwing snow at the Earth. It would actually just melt. And even if it didn't melt, it still wouldn't have geysers because the whole gravity and dynamics is wrong. But snow cannons, people, you have to make a joke when planetary scientists finally are capable of naming something with such a cool name as a snow cannon. So get out of the way. Everything out in the Saturn cistern. Enceladus has snow pointed your way. Okay, from one icy body to another. Our next story takes us to, and I have to look at the word, takes us to comet 67P Chuyumov-Gerasimenko. This is the comet belovedly called 67P Chirigiri that was studied by the Rosetta mission from August 2014 through to September 2016. This object was observed from a point when it was far enough away from the sun to be quiet and dormant, and all the way through getting snuggled up as close as this comet gets to the sun and being as active as this comet can be. During this period of observation, Rosetta was able to observe a myriad of dynamic changes on the surface of this object. And some of these are just like the kinds of things you really don't expect to be able to study. This particular comet is made up of two large blobs, kind of roundish, ovalish blobs of material that are joined together by a smooth neck of ice and dusty debris. And observing in this region of the comet, they were able to spot a location where a 10-meter across boulder got flung off of a cliff, landed on the smooth surface below, and then proceeded to bounce and roll. They didn't just see where the rock started, they also saw where it ended up and all the craters it made as it skipped like a skipping stone across the surface of Chirigiri. This is just kind of cool. And this wasn't the only dynamic change they were able to observe. They were also able to see, as the object got more and more active, areas that outburst material into space a bit explosively, and also cliff faces that collapsed. And all of this was made possible thanks to collecting 76,000 high-resolution images spread over time that could be examined before and after the comet passed next to the sun. And by looking at these changes, we're able to piece together the dynamic evolution of this comet. Now, beyond just being cool in the fact that we're seeing we're seeing boulders bounce across a comet, these observations also make it clear to us just how fragile a comet is. Over time, this comet is going to get smaller and smaller and perhaps even break apart, as we've seen other comets do. But for now, we've at least been able to document in extraordinary detail one of its encounters with the sun. And this allows us to start to understand just how destructive the sun is on comets. And it's kind of cool. That's all I've got. To give you some numbers, during those collapses, it's thought that 2,000 square meters of material was ejected out into space. So with that explosive news, I'm going to end this episode and take your questions. As a reminder, please at CosmoQuest X to make it easier for me to find your questions. And I just had the horrible realization that I may not have opened the chat early enough, which means I may not even be able to see your questions. I did not. You're going to need to repeat your questions because I forgot to open the chat early enough. I am horribly, horribly sorry. So while you copy and paste your questions back into the chat, I'd like to remind all of you that if you ever miss an episode, you can catch it over on youtube.com/c/CosmoQuest. This is where our producer, Susie Murph, is archiving all of our episodes. And those of you who are over on YouTube, I've seen your comments that you're considering no longer watching because there's too much doggy goodness. We are working to restrict the dogginess to the Q&A part of our episode, where we do thank people who donate during the show for all the good they do by bringing them, well, the adorable face of whichever dog happens to be in the room while the questions are being answered. Thank you for watching, and please don't go away. We like you. We really do. Okay. In addition to that, I'd like to say this episode was brought to you by you. Your bits, your subs, your patronage over on patreon.com/CosmoQuestX. All of these things work together to make it possible for us to pay Susie and Annie to be able to get this show out to you most Mondays through Fridays. In addition to our daily space episodes that come out at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time, we also bring you the Sunday Science Hour. We co-stream a variety of other events, such as the weekly Space Hangout and Astronomy Cast. And we also bring you lunches, landings, and other events as they happen. So please consider giving us a follow to find out whenever we're going to go live. Now, before I answer your questions, I'm going to thank a bunch of you with doggy goodness. Sorry, everyone on YouTube. So this is a thank you to Trekker Kev, Wayne Johnson, Kevlar 1066, Commander Unifex, William Shakespeare for the follow, and all of you, Veronica Cures, hopping in on the Bits wagon, all of you make it possible for us to do everything we do. So thank you. Please don't lick my mouse. And yeah, that's all I've got. Thank you. Okay, so I am going to hop on in to the chat and see what all I've got. Fenmel comments, made it in time to see Eddie. Okay, so I'm going to work on switching up the scenes. I am trying something new today that so far seems to be working. I am using a Stream Deck to control my screen, and I can see the Stream Deck because it's right here, whereas I can't always see my screen because it's way over there. So hopefully by adding to the technology, we're going to slowly be able to get the show to be much more streamlined as we bring it to you. All right, looking to see what else we have in here. Thank you. Thank you, Franca, for the bits. Thank you. Come on up. Come on. There we go. There we go. Such a good boy. Such a good boy. Come here. Still a few more. Good boy. He knows it's time for bits. He enjoys this time of his day. Okay. Looking to see what other questions we have. Whoa. Eddie is moving my desk because he can do that. I'm sorry I forgot to open chat. Yes, repeat your questions. I make mistakes. So Open Cage 5 asks, might the predictability... I clicked weirdly on my screen. Might the predictability be because Io is smaller and there's less data to consider? No. The issue is actually more of here on Earth, the processes that drive volcanic eruptions are driven by heat trying to escape our planet in ways that aren't driven by any external mechanisms. On Io, the heat is driven by the interactions between Io, the other Galilean moons, and Jupiter's gravity, essentially repeatedly squeezing Io like a squishy ball and heating it up on the inside. It's not exactly clear exactly how this leads to a periodic eruption, but what is put forward is when you have this massive of a volcano, flat out, this massive of a volcano, the smaller factors that end up affecting the smaller volcanoes that we have on Earth, because we're not getting driven heating like Io is. When you have smaller volcanoes, you have to worry about the minor geology differences. We know from Iceland that if you build up ice and snow on a volcano, that changes its behavior. You melt that ice and snow, it changes its behavior. All of these effects don't matter once your volcano gets to being hundreds of kilometers across. So when you have a small ball that's constantly getting heated and heated and heated, which is what Io is, and then you put a giant volcano on it, you have this constant inflow of material, just like with the geyser Old Faithful in Yellowstone. And this constant infilling of material is able to drive regularly recurring eruptions. Now, it's not entirely periodic, just like Yellowstone's Old Faithful isn't entirely periodic. There was a disruption that caused throughout the early 2000s Loki to behave in a more chaotic way. But the more we can observe this, the more we're going to be able to understand it. And this may actually eventually help us understand our own world and past volcanism on our own planet. And let's face it, volcanoes are just cool. Volcanoes are just cool. All right, looking to see what else is going on. Has Juno noticed any more eruptions, or are these purely ground-based? I don't think Juno is in an orbit that allows it to study the moons. Its orbit brings it fairly close to Jupiter in a polar orbit that then dives down deep beneath. There was a really cool data visualization of the orbit of Jupiter posted yesterday. Let me see if I can find an image to share in the chat. Yeah, here's... I'm sorry I can't bring this up on screen. Actually, I might... No, I can't bring this up on screen. Here's a video that you can watch on your own. So the Raven Lillian asks, the volcano on Io, Loki, is there a link to an article on that? I'm glad you ask. We actually are producing every episode of this daily space as a scripted, highly produced, or at least mostly produced podcast. And along with each podcast are links, show notes, and a transcript. If you want all of that, you can get it in your inbox by becoming one of our Patreon patrons at patreon.com/CosmoQuestX. And this is really one of the best ways that you can help us and allow us to provide you with the best, well, astronomy and planetary science content we can. If you don't want to follow us over on Patreon, we totally get it. We totally get it. You can also get everything at dailyspace.org. So yes, we will be sending out links to everything. Give us an hour or so after the end of this episode so that I can get everything posted. So it's Susie that handles Patreon. I put together dailyspace.org, and together we make the show possible. It is a team effort. And thank you guys for everything that you do that allows this to be part of what we do for our job. Veronica Curie is like, too much Dougie is not possible. Thank you. I agree. But I respect the people of YouTube. Falco comments, the YouTube crowd prefers cats. I can't speak to that. Binary Blaze points out, Kerbal asks if Rosetta is still active. I don't know. I think Rosetta is currently in sleep mode, but I don't know if they self-destructed the spacecraft, as in like they can't contact it ever again. I just don't know. So Larry comments, what? Who does not like doggos? You don't have to clean up after. Grr, that's woof. And Eddie just sat through that. Eddie is chill. I agree. But a lot of people tune into YouTube expecting something that is closer to a television experience than a hanging out with friends experience. And Twitch is really a platform where we get to hang out together, live, talk back and forth. And with this show, we're trying to produce a hybrid experience where the first bit is a live news with periodic anchor commentary like you might get in a local broadcast of what's going on in space and astronomy. After that, when we go into the questions, this is the hanging out and talking with your friends about news. If you're showing up, though, for CNN, you can somewhat tolerate the local cable news, but you're probably going to not like the hanging out with friends part. So in creating a hybrid show, we're going to annoy people on both ends. I'm sure that there's people who come in and catch our show on Twitch, watch for a few minutes, and see that when I'm doing the news, I'm not really interacting with the chat, and they're going to go away. They're not as vocal about their sadness. The people on YouTube, they're more vocal about their sadness. Okay, scrolling on through the questions. So Refs Matt says, after you told us about Loki, I went to see where it is on Io, on the trailing or leading hemispheres. Trailing Io's orbit has an interesting relationship with other Galilean moons that leads to its extreme surface tides being caused by Jupiter itself. That's more of a comment than a question, but it's a useful comment. We really need to get Julie to come on and talk about this object. She's actually also really active over on Twitter as Loki Volcano. And yeah, there's a whole lot of science going on that is completely worth studying. This is where I feel the need to point out I'm an astronomer who only plays a planetary scientist. So I don't know those details as much as others, especially those who study Io, definitely do. So Hanny asks, does Io coat any of the other Jupiter moons with sulfur? I don't know, and I actually don't know what the composition of its materials are. I do know that some of the materials it spews up end up becoming ions in the radiation belts of Jupiter, but I don't know those details. This is making it clear we definitely need to have Julie on. So the Raving Lillian is talking to Larry, continuing to scroll. Binary comments that favorite human just walked by and saw Eddie and giggled. That makes me happy. Eddie is definitely a big dog, Fenmill. He is all of between 70 and 75 pounds, and then he has an additional several inches of fur on top. Commander Unifix says, if one of our support volcanoes was to blow, how high Oh, I think he means super volcanoes. How was to blow? How high could the ejective reach? Definitely order of 30 kilometers. Wait, no, I'm doing that wrong. 10 kilometers. I don't know if it can go tens of kilometers. I suspect it can. One of the real questions is, how does the supervolcano go? Volcanic eruptions come in many kinds. In general, you don't worry about flying over any of the Hawaiian volcanoes because they're just kind of casually oozing. They send liquid stuff out that consumes houses, fences, cars, and other things that we generally would like to keep. But I think it's better for the overall economy when volcanoes just gently ooze over everything rather than throwing material up into the upper atmosphere as some of the Icelandic volcanoes have been known to do. These are the differences between how much gas is in the eruption, how much water went in and then suddenly became steam and tossed material up. The composition of the stuff that's getting ready to eject is what determines what kind of an eruption that you're looking at. If one of our supervolcanoes were to crack through the surface, it could easily ooze all over the Great Plains of the United States, which would not be pleasant. Would not be pleasant at all. But that kind of an eruption might not send material extremely high up. On the other hand, if there were a sudden explosive volcano where all of the energy got released in a few minutes instead of a few months, yeah, I don't know what the limits on that kind of an eruption would be. So basically the answer is, it depends. Larry asks, has any Earth volcano reached orbital velocity? Not that I'm aware of, but historically there were some massive eruptions that paled compared to anything in modern times. Krakatoa, which is one of the largest volcanic eruptions in the modern data collection era, it didn't succeed in doing that. And all because the material leaves the volcano at escape velocity doesn't mean that drag forces and other forces aren't going to keep it more down to earth. Hanny asks, does Io just erupt from the same volcano, or are new volcanoes popping up all the time? Both. There are long-term volcanoes that just keep going and going and going, of which Loki is one of them. But there also seem to be smaller volcanoes that crop up that perhaps we don't know about, or didn't know about, or are new. We need more spacecraft to study it. Okay, Falco asks, do the volcanoes always erupt from the same spots, or do they move like the oceans under tectonic plates on Earth? So here on Earth, we see two different kinds of volcanoes. Those that form at the plates, junctions between plates, where magma is able to seep out along the rupture line where two plates come together. We also have hotspot volcanoes like the Hawaiian Islands that, for whatever reason, there's an angry hot plume of material underneath the crust that just keeps burning through the crust. So as the crust moves, it moves old islands and a new island emerges that is relative to the inner part of the Earth, still in the exact same place. With Io, I don't think 30 years is enough time to say whether or not it has any plate tectonics or to see dynamic motions of the crustal material relative to the sources of the magma. That's a question for Julie, and it's a really good question. I just don't think we have the data sets to be able to answer it yet. Looking to see. Yes, I do love volcanoes. And I am allergic to them. It turns out if you're allergic to sulfa drugs, you may be allergic to some of the molecules coming out of active volcanoes. Yeah, these are my problems. These are my problems. Commander Unifix imagines the ejecta from one volcano getting a boost as it crosses another that blows and gives it a boost, a support volcano. I like the way you're thinking. I'm now imagining like hot air balloons over Io that are constantly getting reheated and lifted as they pass over volcanoes. Yeah. Okay, looking for more questions. Ramahe1110 says, I've been to a black hole once, but I want to know more. I like the idea of visiting one. Okay, looking for more questions. Yes, Susie is learning more and more software as we go. We are slowly giving her a graphical arts degree. Looking for more questions. Don't try and take your support volcano on an airplane. That is one of the best comebacks I've seen in a while. You know, chat, I don't have time to react to everything you said, but you are the most delightful chat. I'm really enjoying all of the randomness that is occurring today. So Bill Nash is asking, if a planet doesn't have much in the way of an axial tilt, what would its seasons be like? So for those of you who don't quite understand, I have an entire bag of planets. One moment while I grab a planet. Eddie, you're on my desk. No. Move. You're not moving. Okay. Okay, when I said I had a bag of planets, I was not kidding. And one of these worlds happens to even be Io. These come to us from John Jorst. It is not food. And he makes these amazing paper models. And I'm looking for a paper model of something that has clear axial tilt. Okay, I'm actually going to simulate this with a slightly bent coronagraph. Okay, so the reason I'm doing it for this is because you can see tilt. Now, if you guys are the sun and this is the object orbiting you, if the axis of rotation is such that the equator is constantly in line with the sun, the equator always gets maximum sunlight, and the North Pole and the South Pole constantly get glancing blows of sunlight. So you can see glancing blows of sunlight where my fingers are touching this object. Now, if instead the world is tilted, you can see how at various times of the year the object is going to get more light on one pole. As it goes around, it'll eventually be lined up like this. It will get the light on its equator. It will eventually get the light on its south pole. And this axial tilt is what causes the when it's pointed towards the sun, summer, and when it's pointed away from the sun, winter. Now, if you don't have that, you don't actually get seasons. So worlds that are pretty much upright, like Jupiter, they just don't have seasons. It's the way it is. It's kind of boring. Sometimes you get a boring feature to an exciting world. Jupiter, otherwise, super exciting world, kind of doesn't really have seasons. It's the way it is. Okay. So scrolling for more questions. Larry Weird asks, does travel insurance cover Vogue allergies? Or VOG? This is volcanic fog. No, it doesn't. I was so sick. I thought I was like getting pneumonia or something, and it was just allergies. I was completely fine 10 minutes after leaving the big island. Okay, so I think I've gotten to all of your questions, and I think it is time for me to go work on putting together the podcast version of this show. We're still trying to get our podcast to get notice, and we know that there's a whole lot more people out there listening to podcasts than watching us here on Twitch. So if we could get some of those people who are already listening to podcasts to also listen to our podcast, it would really help. It would help make a more scientifically literate society. It would help grow our audience. And let's face it, who doesn't want to get science into the heads of more humans? So if you can share our podcast with everyone you know who listens to podcasts, like just post about it on Facebook or something. That little post could go a long ways. And you never know whose life you're going to change by introducing them to science. So that's my request for today. Can you let everyone know that we have a podcast? And after you do that, Susie's going to beat me up if I don't remind you of this. We're also trying to really promote our YouTube channel so that we can open up some additional features. It turns out YouTube only allows certain features to channels that have large enough audiences. And our YouTube audience just isn't quite large enough right now. So if you could first let people know that we have a podcast, and second, go sign up for our YouTube. It's free. It's just going to sit there going, hi, I've got science. If you could do those two things, it would really mean the world to us. So once again, this has been an episode of The Daily Space. I'm Dr. Pamela Gay, and I am here along with my host, Annie Wilson, most Mondays through Fridays to bring you The Daily Space at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London time. Annie is back here on Sundays at the same time to bring you the Sunday Science Hour. In addition to this, we bring you, launches, landings. We co-stream other science like the weekly Space Hangout and Astronomy Cast. So give us a follow. It's free. Find out when we go live to put science in your brain. We are a production of the Planetary Science Institute, a 501c3 dedicated to exploring this solar system and beyond. So if I can succeed in doing this, I can start the credits rolling. I did! It worked! I figured it out! Okay, so wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember to go outside and look up, because that's one sky that we all share. And I'm really amazed at all the people who've contributed to our episode today. Thank you. I'll see you on the other side. Bye-bye.